Looks like a beautiful day outside. Perfect day for debunking with this mount. So I'll head out now from the hotel and let's see what we can come up with. One of the common experiments done in the Flat Earth game is to look across a body of water to see if we can find any evidence of curvature. I was looking across at Rottnest Island. Now that's about 12.5 miles across the ocean. We can measure that. There you go, 12.5 miles, 12.6. So it's enough distance away for there to be very clear evidence of curvature if the Earth is not flat.
If 12.5 miles is sufficient distance to give clear evidence of the rotundity of the Earth, then 30 miles would be even clearer evidence, right?
And what I did is I obtained a couple of videos, one from the top of the hill and then another from down near at beach level. So my estimation of the elevation was about 2 meters down here at the beach and perhaps 30 meters, 100 feet at the top of the hill. So looking out across at Rottnest Island from those two different elevations, we should see some evidence of curvature, some evidence of objects or land masses being hidden by that curvature. Now, if we can see that hill and the size of the hill changes from the two different elevations, that's going to be some evidence of curvature hiding the object.
Come on, is it really? Doesn't refraction enter the equation at any point?
So without any further ado, I'll just show you the two shots from 30 meters elevation and from 2 meters elevation. You can make up your own mind. So here is a still shot taken from 30 meters elevation at the top of the hill, 12.5 miles looking across at Bathurst Lighthouse on Rottnest Island. You can see clearly the ground level and the hill that the lighthouse is built on. Now, when we went down to the water's edge, we were only 2 meters above the water, and you can see that that ground is now completely hidden by the curvature of the Earth. We can only see the lighthouse. 12.5 miles from 2 meters elevation, you can see there is a significant amount of that ground hidden.
Okay, let's see what Earth Curve Calculator says. 6 foot elevation, that's at the beach, with a target distance of 12.5 miles, the horizon is only 2.9 miles away, and the hidden height of the object is 60 foot. For those who think in metric, at just under 2 meters height at the beach, the target distance is 20 kilometers away, the horizon distance is just under 5 kilometers away, and the target hidden height is 18 meters. The tower itself is 19 meters tall. It stands on ground that's 14 meters off the sea level. So, yeah, seems legit. If you look at these photos side by side, you can conclude logically that there's at least 14 meters missing, that's the land, and what should be missing is 18 meters. You can assume there's a 4 meters missing from the tower. So it's a logical conclusion to think that there's Earth curvature, having not factored in any refraction. So it's a legitimate conclusion. However, if we conclude that there is curvature because the land is missing, not having factored in refraction, then your conclusion has to be at least questioned at any time when that land might appear beyond what you thought was curvature. So this is showing missing land, supposedly due to the curvature, but these following images show no such missing land due to the curvature. Let's remember, this is showing 18 meters missing. Now what we're going to look is for 516 missing feet. If 12.5 miles is sufficient distance to give clear evidence of the rotundity of the Earth, then 30 miles would be even clearer evidence, right? So now, instead of expecting 18 meters to be missing, we're looking for 157 meters to be missing. The Earth curve calculator now says at this distance there should be 516 feet missing from the frame. And if you compare the height of the building with the missing 516 feet, you see that the building should be beyond the horizon by 234 feet, the top of the building. Now we're seeing a day when there's less refraction, so you can see objects that would otherwise be hidden by refraction bending the light down in its journey from where the object is reflecting the light to your vantage point. When there's refraction, that light is bent downwards so it doesn't reach your vantage point. Remember, we're looking for 516 missing feet. That building, the top of that white building, should be 234 feet under the horizon. The top of that building should be 234 feet beyond the horizon. It obviously isn't, that's why we can see it. Refraction is what hides things, not curvature. Now we're going to look at more missing curvature. There's the building, the target building. It should be 387 feet beyond the horizon. It isn't. It's obviously not beyond the horizon. Refraction does not lift things that would be 387 feet beyond the horizon, lift them up. You see, refraction bends light into the denser medium. The denser medium has to be the medium that's closest to the surface of the Earth. If it was denser and higher, it would mean that between it and the surface there would be a lighter medium. And that's just not how buoyancy works. The densest medium drops lowest. So the light drops into that medium. It doesn't warp its way upwards and round a curve to present an image to you. It simply bends light down into the denser medium. That's why sometimes you can't see things, and when the refraction is minimal, you can. That's what's happening. From an altitude of 1,062 meters, that's above sea level, our target distance this time is 293 kilometers. The hidden height is 2,449 meters. The horizon is at 116. It looks like this. This is our vantage point, 1,062 meters. This is the distance to the horizon. Our target distance is not Montserrat here. It's this mountain range here. The height of this mountain range is 2,000 meters. The hidden height is 2,449 meters. That's the hidden, beyond the horizon. And yet, here we have it right there. The mountain on the left, the darker mountain, is Montserrat. The one in the center is much farther away. So, knock yourselves out. Here's the whole report. Enjoy.
Des de la Serra de Tramuntana de Mallorca ha fotografiat Catalunya. Mirin quin recorregut ha fet o fa aquesta imatge que ha de fer aquest fotògraf amb els seus teleobjectius. Des de la Serra de Tramuntana ha de passar al mar Mediterrani i trobar aquestes coses. De fet, per exemple, Collserola fa 512 metres d'alçada, la Mola 1.104 i el Cadí 2.600 metres d'alçada. I les ha fotografiades? Doncs sí, i la prova són aquestes fotografies, aquestes imatges que ja veuran que Marcos Molina realment ha fet des de la Serra de Tramuntana. Són imatges realment que s'ha de fer en dies de visibilitat excepcional, però aquí es veu, per exemple, Montserrat. I això, insistim, de la Serra de Tramuntana. Aquí també es veu tota l'àrea del Cadí Nevada, per tant, doncs, sens dubte, és factible veure d'un costat a l'altre, des de Catalunya a Mallorca i des de Mallorca a Catalunya. Això és una imatge també, ja ho veuen, de la Serra de Collserola a sobre de la ciutat de Barcelona.
So you see, the reason you cannot sometimes see things at a distance is due to refraction. When you're within that field of denser atmosphere, the light is being bent down. When you elevate yourself above that denser atmosphere, the light is no longer being bent down. When you elevate yourself higher still, you get these effects. You don't see the horizon here, but obviously there's something here letting us know where the horizon is. I wonder if you can spot it. So the situation we're in right now is one where the physics underpinning the globe theory are being overturned. The phenomena that has supposedly supported the sphericity of the Earth is being debunked. And now the rotation of the Earth is also being debunked. It has been debunked many times, but we now have technology and the means to promote our discoveries far greater than they had 150 years ago. So it was a belief, it was a fantasy, the idea of outer space, of nebulas, of distant possible black holes which can suck in light due to their extreme gravitational pull, despite photons not having any mass and therefore no mass on which gravity can pull. These ideas were only fantasies, and you have to understand this. Flat earthers aren't just people who rebel against authority. We are the real skeptics. We are the ones who question things, which is what skeptics are supposed to do. We are supposed to question what we're told, question what's being proposed. That's what skeptics do. It is we flat earthers that are skeptical. You are cynical of us flat earthers. Some flat earthers are cynical about globelings too, but some flat earthers understand that when your belief system crumbles, people will resort to desperate means.